You guys having a lot of fun at Ignite? All right. So my name is Subramanian Ramaswamy, and since that name is just going to roll right off your tongues, I go by something smaller. You can call me Mani. So my name is Mani Ramaswamy. I'm a program manager in Azure Compute, in particular, leading one of the teams in Service Fabric and containers on Service Fabric. With me?
Yep. Hi, I'm Patrick Lang. Currently working as a senior development engineer on AKS, but I've been working on containers since we launched these 3 years ago over at Ignite. Was it 2016?
Yeah.
Sorry, with Windows Server 2016. And so, like right now, I'm focusing on some of the extra things that we need to get containers in production with Kubernetes. And so that's an open source project, and a lot of stuff I'm doing is actually in the open as well. So I'm serving as co-chair of the Windows Special Interest Group in the Kubernetes project, as well as doing the work on Azure Kubernetes Service. So.
And we're going to be talking about Windows Server container orchestration. So a lot of this talk is going to be dealing about Service Fabric and Kubernetes, so we're going to dig a lot more into those two orchestrators. So what are the takeaways we want you to take away today? One, Windows containers are key for a lift, shift, and modernize exercise. So a lot of folks have existing apps, and you want to be able to lift and shift them into the cloud. You get some of the benefits of containerization, like better agility, more density, so you can save on VM costs. And eventually, you want to add new microservices or new container applications alongside it. So Windows containers are a stepping stone for you to allow to lift, shift, and modernize your workloads. And the second thing is, Azure provides you with a variety of options, like depending on what your scenario is, whether you're building simple web apps, or whether you're building a state of services or microservices that need to talk to each other, or whether you have something that just runs once, Azure provides you with a variety of container technologies for you. So these are the technologies that we offer in Azure. So we'll go over some of these in a lot more detail. Service Fabric and Kubernetes in a lot more detail than the others. So app service, which is very good for web applications. Kubernetes and Service Fabric are more container orchestrators, which allows you to run a lot of services and have those services talk with each other and deal with that. Container instances, again, similar to app service in the sense you can run single container applications quickly. And we have, of course, the batch service for run one scenarios. So, the thing is, well, you have a container. What do I do? So there are three steps when it comes to running containers: build, deploy, and operate. So you want to be able to build the container image. And when you're building, the thing to watch out for is, well, do you have a pipeline that is making sure that your dependencies are getting updated? For example, OS patching, like make sure that those patches are built into your container image. Make sure you have set up a pipeline to do that. Then you have to come to, when you think about deploying, there are a couple of factors for you to think about here, many factors, but the two that we highlight here are, one, well, you're going to have multiple environments. So you will have to first figure out here, like, how do I actually set up my multiple environments? Maybe I have a staging environment, a production environment. Maybe I'm running something on premises, something on the cloud. How do I configure them differently? And all configuration should be treated as code, because without that, you're breaking stuff into your images, which means like when you go from environment to environment, you're going to run into problems, and you don't want to deal with that. The final thing is operate. So once you have your containers running, now your job isn't done. You still need to make sure that you have a good monitoring and diagnostics pipeline. So you monitor the health of your containers, like what's the use, how many people are using it, what's the load demand, do I need more instances, do I need more capacity? At the same time, if something goes wrong, of course, we never write code that has bugs in it. If something does go wrong, then you need to make sure you're set up to grab the diagnostic logs and take care of it. And of course, you want to scale on demand. So a couple of talks highlighted there which give you more details. The end of the session also, we call out a bunch of the relevant talks. Some of them have already happened, and which you can see recordings of, and some of them that are going to happen today and tomorrow. So with that, I'll hand over to Patrick to talk more about how we build containers.
All right, thank you. Yeah, so if you followed Wajon and Taylor's previous talks, they went through the steps of building your first application using Docker for Windows, typically on your Windows 10 laptop. I mean, you could build on server if you want, but sort of the first step a lot of people do is figure out, can I containerize my app? Once you want to actually roll into production, you need to be thinking about, what is my strategy for being able to patch this and roll out other updates? So since everything in a container is layered, you can basically walk back down that chain and find out when something has changed. So all of the Windows containers start from either the Windows Server Core, the Nano Server, or the new Windows image that they just released. And so you're picking one of those based on level of compatibility you need. Microsoft also publishes several more containers that have common things pre-installed. Like we have one that uses IIS that layers on top of Server Core, and then we've got another one that uses ASP.NET layered on top of that. So when Patch Tuesday comes around and we've got a new Windows cumulative update rolled out, Microsoft will go ahead and actually update this bottom layer here, and then we actually have a cascading build system that will build things that are on top of it and then publish them out there. So for your organization, where you've got a layer at the top, what you need to be able to do is be able to rebuild and just say, give me the latest ASP.NET. So you don't have to go like hunt and find the patches, you just turn the crank on the same tool that you already have there. And so one of the new tools that we have available for that is actually at Azure Container Registry tasks. And so what you can do with that is you can either launch a build from any machine that you already have, or you can also set up a webhook to your repo so that whenever something changes, it will automatically be able to rebuild the container for you. It also knows what these different images are up here. So it will walk that dependency chain for you. And so in this case here, if we see that the ASP.NET image is updated, your container could automatically be rebuilt using a task in Azure Container Registry. So if you're looking for something just to get your first app in production and keep it up to date, this is something that you could combine very easily with something like Azure Container Instances or Azure App Service to get your website up and running. And just to give you a quick view of what that actually looks like. So over here I have the same source file that was on that slide. And so this is a Docker file that follows what they call the builder pattern. And so what this is doing is it's actually using the .NET SDK that's already available in a container. And what it's able to do is take the local source code in this repo, build it in a container, and then it copies just the outputs, and then that's what's going to get published. So what's important about this is you always have a very clean build environment automatically, but you're not putting your source code into the final container as it's being built. So from there, you can go ahead and do a build with the ACR build command from the command line. That will just do a build immediately. One of the things that's kind of cool about this is that, if your machine is slow or or for some reason you don't have Docker installed on that machine, you could just launch this task and it's going to go build in the cloud for you. And so right now we see that it's waiting for a build agent, and it's going to take more time than I have to wait right here. Within probably a few seconds it'll start building, then the build process will take a few minutes. But in the end, what's going to happen is the registry that I specified here, I've got one called Ignite 2018 Registry, and I told it to tag this container as Web2, will show up in this list within the Azure Container Registry on the portal under the repositories here. And then now this is something that I can reference from another service and deploy. And then if I wanted to set this up to build automatically, if I had this code out on GitHub or in a Visual Studio DevOps instance, then you could just use a webhook to go ahead and have it automatically build that. I don't have that set up right now, but there's a whole nother talk on that topic. So, when you're getting into production, you need to make sure that you've got a strategy to patch. And, when you're building a container, you're basically building that automation right then and there. And so this Azure Container Registry makes it easy. If you've got a more sophisticated build process, switch over, then you can actually use Azure Pipelines, which is part of the larger Azure DevOps suite. And Jessica Dean did an excellent talk on that. She was running a Linux app, but you can build Windows apps as well using the same pipeline. So if you need to do things like pull source code from multiple repos, pull in other artifacts, let's say you've got a database connection library from a third party or some extra chart controls and things like that, you can store all of those as artifacts in Azure DevOps, bring all the pieces together that you need, do your build, put into a container, and then run deployment tasks from there. So this can basically tie into any of the container orchestrators that we're going to talk about, so you can have whatever workflow you want in terms of the build and approvals, scanning, and all that automatically rolling out into production. So the way that you start secure is to get your right build environment set up at the beginning, so you're never hurrying to do patches. It's just automatic. Okay. Do you want to take over here?
All right, so when you look at the elements of orchestration, what constitutes an orchestrator, there are a bunch of challenges that comes when you're running like several services in the same cluster. Like, for example, scheduling, what runs where. You might want to set some affinity or placement constraint which says, hey, I have these two workloads that it's probably preferred to run them on the same node. You might want to say something like that. Or I want workload A to run on a set of nodes that's different from workload B. You want to make sure that you have health monitoring set up, and health monitoring not just set up, but being part of the platform, because you'll have to make sure that you know the health of your container services. If they go down, you need to be able to restart them. If they actually move if they move VMs, then you actually have to look into, hey, how do I discover my service? Because my service IP address just changed because it moved VMs. And these things, like when you're running it in the cloud, one of the things to keep in mind is, even if you have a 99% availability on a VM, when you actually stitch, say, 5 of them together and form a cluster, your net availability of any one node going down is 0.99 raised to 5, which is 95%. So that's something that you need to handle for. There will be failures, and you need to make sure that your system is built against it. And these are some of the things that orchestrators provide to you. And of course, you want to be able to scale. Like you might want one instance today, tomorrow it might be Black Friday, and you might want 100 instances. And preferably, you want it to be something out of your hands. You might actually say, hey, just scale automatically based on, say, if I hit 80% CPU, keep adding more instances. We already talked about service discovery and networking in a bit. So again, key that because services are going to move from one node to another. So it is required that when services actually do talk to each other, they are not hard coding any IP addresses. And they're relying on the orchestrator to tell you, hey, where that actual IP address is through some, say, DNS lookup or something like that. Okay. And finally, app upgrades. So gone are the days when you could say, hey, I'm down for maintenance, 3 hours, come back tomorrow. In today's world, it's not acceptable to have any downtime. Like, we all do banking and everything through web applications. So if our bank website is down and doesn't allow us to do transactions, like it's a blocker for people. And so you want to make sure upgrades are non-invasive and non-impactful, so you're able to upgrade without having any downtime. So these are things that you look for when it comes to orchestrators, because these are the things that you would have to write code for otherwise.
All right, thanks. Yeah, so one of the simplest orchestrators that we have available on Azure is Azure App Service. This is something that was built to make it really, really easy so that you could build, deploy, and then basically run websites. It's sort of an evolution of, first we had the Azure Platform as a Service, but Azure App Service basically brings in all the features that you need to run either your selection of code, or now you can actually run a container there as well with any dependencies you want in it. So if what you want to do is get a website up and running, get DNS, SSL, all that stuff hooked up very, very quick and easy, Azure App Service is a great solution for that. And that supports Linux containers as well as Windows container support is in preview right now. And so I already talked about the Azure Container Registry stuff there. So that build's still running on my laptop, so I'll just keep going here. So the Azure App Service basically has some built-in orchestration in order to keep your application up. And so you can do things like tell it, okay, here's a new container, go ahead and deploy that, replace it with the old one, and it'll do the things that you need, like updating your Azure load balancers and all that you need. So you could actually hook this up, with the Azure Container Registry tasks, and then have a website that's basically updating itself automatically. So once you're, so once you're up and running with there, it's pretty simple to stay up and running. But as you're building more sophisticated apps, that may not necessarily be websites, then you might want to look at some of the other solutions we have available. So one of the first ones there is Azure Container Instances. So this will let you run any container with a single command. You don't need to worry about setting up a VM or anything like that. But one of the differences from the Azure App Service is that rather than just having port 80 and 443, you can run any application you want in this. So, if you had a custom database, you could run that. If you had a game server, you can do that. But the containers come up quickly, and they get an external IP, then you're up and running, and you're basically have a very cost-effective way of running it because the billing is all done per second. So if you need that, burst capacity, to handle extra load for just a certain time of the day, rather than having a bunch of idle VMs, you can just spin up containers, run those for as long as you need them, and then shut them back down. And that model can actually be hooked up with the Kubernetes orchestrator using a tool called Virtual Kubelet that Corey had mentioned, and they did a demo in Corey Sanders' presentation earlier. But there's a whole session on this that Ria did, and this is able to run both Windows and Linux containers on Azure Container Instances. And so you have the choice between either using the Azure Resource Manager API, or you can use the Virtual Kubelet if you want to use the Kubernetes API to manage that. And then next we have Azure Kubernetes Service. So this is the Kubernetes open source project, but we've packaged it up into a managed service so that way you don't have to be an expert in how to deploy and maintain this. All you do is say, I want this many nodes, and I want this version of Kubernetes. It sets everything up for you, and then you have your management endpoint right there, and then from there, all the standard Kubernetes tools just work. You don't need to think about how you're doing things like patching, maintaining the VMs. You don't have to come up with a separate strategy for how do I move from Kubernetes 1.11 to 1.12. It's all just part of the tool, because you can just go in there and do AZ, AKS upgrade. It'll upgrade to the new version while keeping all your services online. So it's a very nice service if you want to get into the Kubernetes ecosystem. And I'll be talking about Kubernetes in some more detail later. And then so the next service we have is Service Fabric.
Yeah, so I'll be talking a lot more about Service Fabric and Service Fabric Mesh. But Service Fabric is the orchestrator that's developed within Microsoft and used for a lot of the Microsoft first-party services and is available externally. So it supports both Windows and Linux containers, and you can do your lift, shift, and modernize by bringing your existing apps as containers into Service Fabric and then running microservices, your modern greenfield microservices side by side alongside in the same cluster. And it's available on Azure, Azure Stack, on-premises. I'll talk about that a bit more. And the other service that we recently previewed a few months ago is Service Fabric Mesh. So one of the challenges with Service Fabric, it gives you a lot of control because you own the VMs, but the programming models and everything are just cluster aware, so you can add VMs and you own the VMs. A lot of customers told us, hey, we don't really want to worry about the VMs. We just want an app platform that we provide you with an app manifest where how the services talk to each other, but without having us to do anything with respect to VM, storage, networking, any of that stuff. So that's what Service Fabric Mesh is. Again, it's built on Service Fabric, but it's an app platform, and it can run the same thing, Windows and Linux containers. It provides you with the same stateful paradigms as Service Fabric does, and it's consumption-based billing, whereas in the Service Fabric clusters, you're paying for the VMs. So I'll talk a little bit more about this. This slide pretty much goes over the earlier thing that I talked about when it comes to orchestration. What are some of the challenges? You have to worry about failover, health and monitoring, service discovery, all those things. And with Service Fabric, it's a platform that solves these challenges. So all these challenges go away because all of these things are built into the platform by providing you with easy zero downtime upgrades. So it provides you with lifecycle management, so you don't have to take any downtime. It provides you with inbuilt health monitoring, provides you with stateful paradigms for data persistence, and it essentially makes sure that your services are always available, because if a service does fail over, the platform moves it to another node, makes sure that all the IP resolution is handled transparently to the app developer. And this talks a little more about where you can actually run it. So if you look at the bottom, you can see that it's the same piece of code that runs in your dev machine in your SDK. It's the same code that runs in Azure or on premises. So the idea here is whatever you're developing and debugging on your local machine, all what you're saying is, hey, change my endpoint from localhost to an Azure endpoint, and you're deploying the same thing. So we have three offerings. I alluded to them earlier. So one is called Service Fabric Standalone. This is essentially the bits that we give you, which you can run on your local box, and you can also use that to stitch together a cluster on your on-premises, which means, like let's say you have a ton of servers lying around in premises, you can stitch them together to form a Service Fabric cluster. Then you have dedicated Azure Service Fabric clusters, where Azure will actually stitch together the cluster for you, and we'll make sure that we place it in fault domains and update domains so that you have maximum resilience. But you still own the VMs at that point. With Mesh, you don't own the VMs at all. It's completely serverless. It's just an app platform. So it goes from full control to fully managed, and it goes from most work for you to the least work for you, because with Mesh, all what you have to worry about is the application. You don't have to worry about scale or capacity, like can my VM support this workload? Not your problem, it's our problem. So like again, this goes into some of the things when you're doing standalone, well, OS patching is your responsibility, hardware is your responsibility, all those challenges becomes yours. And with dedicated Azure clusters, some of those problems go away, like OS patching and doing upgrades. But on the other hand, you still own the VM, so you still have to manage them. And with Mesh, all what you're doing is app deployment. So this is kind of how we talk about digital transformation. So a lot of the workloads that you want to move from on-premises to the cloud are existing apps. So the first step is, hey, can I actually take the workloads and move them to the cloud by doing a little bit of rehosting, or if rehosting, you might use VMSS for that, or you might refactor, so which is putting them in containers. So even though you're not making any changes to the code, you're still kind of refactoring it, so you're packaging it differently. And then you are in the cloud, and you're getting the benefits of density and agility. Then you can re-architect, and you can add new microservices alongside it, or you can build your new greenfield application. So those are the 5 Rs, and Service Fabric allows you to cover that spectrum. And you can modernize, as well as you can build cloud-native applications. So I'm going to go over the slides a little quickly so that we have time for demos. And as I mentioned, Service Fabric powers most of Azure and Microsoft services, things like SQL DB, Bing Cortana, core Azure resource providers like Compute and Network are all running on Service Fabric. And even Azure Container Registry runs on Service Fabric. It's not just for internal workloads. There are a bunch of lots of external customers, enterprises in particular, take dependency on Service Fabric as well. A lot of these companies are running Windows container workloads. For example, Alaska Airlines is running Windows container workloads. Zeiss is running Windows container workloads. There are a bunch of other customers who are running Windows containers in production today. This kind of segues into what I'm going to show as a demo. So with Service Fabric, what we really want you to do is to write applications. And there are multiple ways in which you can write applications. So you can specify it as a Docker Compose file, or you can use the Service Fabric manifest, which is what we call Service Fabric native, which is a cluster-aware programming model. So you actually have a lot of control with that. And then we have a new resource-based model, which is very similar to the ARM resources one, which is what we use for mesh, which can be deployed everywhere. But if you see like where it can be deployed, you see that the native application model cannot be deployed to mesh because that gives you full control. And this segues into, let me just do a couple of quick demos here. It's 8.
There you go.
Bigger. Yeah, okay. All right, so here I just have an existing application, Smart Hotel. How many of you folks are aware of Service Fabric? About 30%, okay. So this is an existing application, and I'm just going to show how you can modernize it or lift and shift it to mesh, for example. So I can just, in Visual Studio, we have provided a bunch of integration to say, hey, you can add container orchestrator support, and then it lets you choose, hey, I can choose mesh, I can choose Docker Compose, I can choose Service Fabric. So when you create mesh, you're actually creating a resource application. When you're choosing Compose, it's creating a Compose file. Service Fabric is creating a native manifest. So if I did this, it'll essentially add a few resource files. So if I go back down here, so you'll see that it's added a bunch of YAML files. And all what it's doing is it's actually specifying the application and open it up. And the network associated with it, so you can specify, hey, what am I listening to and everything. And at the point of deployment, what we essentially do is we make that into a JSON file, and it's an ARM deployment. And so when it's an ARM deployment, life becomes a lot easier, and I'll show this in a bit as well, because you can add all your other ARM resources. For example, if you wanted a SQL Server or a Cosmos DB, you can just add to it. So I'll just right-click and show, like, if I do publish. So now you actually, hang on, see. So you can see that if I'm deploying to mesh, all I'm saying is, hey, what is my subscription that I'm using? And this is all pretty much I have to provide. Everything else, you don't have to worry about it, because all what we need is, hey, what's the, tell us like what's the subscription we need to use. We already have your application. We'll just publish it. So I'm not going to publish right now because it takes time, but I will. I have something that I already published. So this is the application. So it's just a smart hole lab, people checking in, checking out, as many of you will do tomorrow. Check out, that is. Now, if I actually go into the portal and if I search for this, it's actually showing up right here. So I'm just going into because I published this as a mesh application, it shows up as a mesh application resource. And I can click on the application, and then what it lets you do is, hey, there are the couple of services that comprise my application. Let me click into one of them. And then it'll give me more details as to how many replicas or how many instances do I have. I can scale to 3, 5, whatever I wanted. And it has a bunch of good things in the portal. Like, for example, this is not going to give me much logs today. But let's say you had another container or another modern application that was spewing to std out or stdr, the Docker logs. So this would actually show you the Docker logs at this point. Like, these applications are legacy apps, so they're not really writing to std out, so you won't see anything here. But these are all things that you can see in the portal, and the number of instances, what kind of logs are you getting. And I can tell you this, having the logs has saved my bacon many a times, because I do something wrong and my entry point is not right, and when I go into the logs, it actually tells me what is wrong, so I can fix it. That's one half of it. Now, let me skip over to another one. So I talked a little bit about the ARM template being the deployment format. So here, it's the same one, but let's actually search for this. So I actually am deploying a SQL Server with this application. And one of the things you will notice that I'm passing the SQL Server as a reference as an environment variable. So what that lets me do is I can create a SQL Server resource using an ARM deployment. And at the point of deployment, it will ask me for a password, and I can provide a password. And that gets passed in as an environment variable into the container. So I don't really have to bake anything into my container image, but the container can now get access to a SQL database. And the command that I ran just before a few minutes ago, let's see if it's still there. So I actually ran a deploy command. Let's see. Oh, wrong directory, man. But, well, these were the two deploy commands that I ran. So, all I did is provide an app site. I can actually try to do this right now. Come on. Not letting me select it. And if I did this, what it's going to tell me is, let's go back. The demo folder, and that's where I want to be. Oops. And if I'm just going to create another one called, say, 3, oops, not in the right folder, it seems. Oh. Yeah, so I'm just not in the right folder, but what it would effectively do there is, instead of wasting more time there, I can just tell you what happens. So when I deploy it will ask me for a password that gets passed into the container, and so I don't have to do anything here. Now, if I went back to my portal and I added, let's see, you actually did see the SQL Server. I did show that earlier, but come on. So when I went here, you can actually see the SQL Server resource here. And so the way I created the resource is just passing in the JSON and just saying, hey, this is the password. At the point of deploying, it'll ask me for a password. I just provide the password, and that gets passed into the container, which is what is being used. Now, the other interesting thing that you can do here is I talked about lift, shift, and modernize. So let me go back to my application. And I can add a new microservice to this. So I can say add new item, cancel, not the one I wanted, add new project. And I can add a mesh application, and let me just call it application 1. And then you can see that it allows me to add an ASP.NET Core application, or pretty much any application I want. And it also lets me use something called reliable collections. Reliable collections are the state store that Service Fabric provides. And what it lets you do is it allows you to co-locate compute and data in the same node, so you don't need an external high latency network access in order to get your data. So I can just do this, and I can just add, this is essentially my modern microservice that I'm adding to my existing legacy applications. So I'll just go click OK. And I already have one open here, which is configured, so I'll just show that. Too many windows open, apparently. Happens.
Too many projects open.
Too many projects open and too many windows. So let's actually do this. So what I wanted to just show you was that, if I go into, well, where is it? Okay, let it load for a few more seconds. Maybe I'll come back to that in a bit when the windows are a little closed. So that's one of the things I wanted to show, and I wanted to show the use case of reliable collections there, where it is just another library that you add to your project. So you just say use reliable collections, and then anything that you're writing is just another dictionary that you're writing from your code. So there is no need of a Service Fabric specific programming model or anything like that. We are plugging into whatever programming model that you are using. Now, a couple of other things also that I will just show is, one, just show off the Service Fabric cluster. So I have one here. So this is an example where I'm running a Service Fabric cluster, and it's a Windows cluster which has 5 nodes, and because I'm RDPing and my mouse is kind of reversed as well to make it more interesting. So what you actually see is, hey, I have 5 nodes in the cluster, and I have an application that is already deployed. The application has 2 services and 4 replicas of 4 instances. So I have, as you saw, I had a web role and a worker role, so I also deployed a similar app, not the same app, to a Service Fabric cluster in Azure. So this portal experience you wouldn't get with Mesh, because Mesh, you don't know VMs. VMs are completely abstracted away from you. But with a Service Fabric cluster, you actually do see those VMs, and you can see the VMs, and you can restart the VMs, and you can do those things. So here I have 2 services, a web frontend and a worker node. So I have 3 instances of the worker role running and 1 instance of the web frontend running. So the app is called Visual Objects. So all what it's doing is, hey, there are 3 things that are running here. Each of those moving objects is a worker role. And just to show you how Service Fabric does some of these things, I can just do things like I can see, hey, the web frontend is running on _0. So I could go to the node, and I could say, hey, do a restart on that node. And it'll tell me it's a very bad idea, don't do it, because you're going to lose a node, and you can lose the service with it. And what you'll find is, sometimes the node comes up very quickly because I'm simulating a failure, and it might place the same web front end on the same node. But if the node doesn't come back, Service Fabric will just move that somewhere else. It'll try to see if it can get a node that it already has the images on, because then you don't have to re-download and reset up. But if it cannot, it'll just move it to another node because there are 4 nodes available. So it takes about a minute or 2. And it takes a minute or 2 because Service Fabric is also making sure that, hey, when the process comes up, it's available, it's healthy, all the stabilization parameters are met. And within a minute, you will find that the service is back healthy again. And right now, you'll see, if I go here, it's all stuck. Now, in a minute or 2, it'll start running again once the service is back online. And as you can see, the service is now back online. So it just failed over the service to some other node, or perhaps it even restarted it in the same node. So, so this kind of shows you an example of failover. And this is the same thing that we use for many other things, like, as an example, when you're doing application upgrades. So in the case, let's say you have 3 worker nodes. We can actually upgrade 1 node at a time, so you don't necessarily lose all the data. You can actually just upgrade 1 node at a time, so your service is still accessible, people still see everything, and people are still able to interact with the service. And same thing, like when it comes to scaling, like you can trivially scale from 1 to 5 nodes. I have a couple of demos on that. Maybe there is time for this. So I have another cluster. I think I have it open here. Yeah, so I have another cluster, and this cluster has well, not this one. Sorry. So I have another cluster, and this cluster has 2 node types. And you'll find that there are 2 kinds of nodes, blue VMs and red VMs. So I'm just specifying that by VMs. And what I'm just going to quickly show here is I'm going to deploy an application. So let's make this a bit bigger. And this is just showing that my endpoint, what I'm deploying to, is the Azure endpoint that I provided. I could do this to a local host. I could do this if it's a secure cluster, just provide the certificate and authenticate. So it's just deploying a 2 container image. And what it's going to do is provisioning the image, which is registering it with the runtime, then starting the application. So it'll come up in a minute or two. And what I wanted to showcase here is, as it comes up, so I did run into some issue, but let's keep going. So one of the things I wanted to show here is, there is this thing called constraints that we allow you to set, and this is being done dynamically. So what it lets you do is I can specify, hey, this service runs on this node, or this service runs on that node. So you can set affinity and placement constraints that way. So I'm going to pause here. I'm just going to keep going and showing you the way that you scale it. There's something that the setup is wrong. But updating is just I'm just saying, hey, I want X instance count of a particular service, and Service Fabric will automatically scale it out or scale it in. Now, this, I'm doing it manually, but you can also set up auto-scale rules that do the same. That I'm going to switch back to my, I think just one more slide on this. So a couple of customer case studies, one internal and one external. So everyone knows who Carl Zeiss is, and the lens manufacturer. So they are running Windows containers with existing code, as well as new microservices running on the same Service Fabric cluster. And this is a testimonial from one of the leads in their group, that they get a scalable platform that can do both stateless and stateful services, and with the container integration, they can run everything in one place. We are dogfooding this internally. There are multiple teams within Microsoft which are either prototyping containers or already in production with containers. So, one of the teams in the finance department in Microsoft is also running Windows containers, and they migrated off cloud services. And what they found is they got an 80% reduction in cost because they get better density. So instead of having, I think I don't remember the exact numbers, but about 100 or 200 VMs, they were able to minimize it to just a dozen or 20 VMs for all their environments, because they could merge all the services and run them on the same cluster, all the environments also, and run them on the same cluster, so they got dramatic cost savings, which is one of the reasons why people do containerization, because especially if you have legacy ASP.NET IIS workloads which have to run on a VM, now you can actually put them in a container, and you can slap a lot of them together in the same VM, so you get better density. So, just going over this, I'm not going to talk a lot more about this, but now I'm handing over back to Patrick to talk about Kubernetes.
All right, thank you. All right, so Kubernetes is a container orchestrator that is managed as part of the Cloud Native Computing Foundation. So it's one of the fastest growing projects on GitHub with an absolutely staggering number of contributors. But what it's designed to do is basically make it easy to commoditize and orchestrate containers by providing like a common layer underneath that's very easy to extend as needed. So the core functionality is that it's able to deploy your applications in containers quickly across a large number of nodes. You can scale things up and down, you can add and remove nodes, and then people are also building on top of that and doing things like autoscalers that are tailored to their solution. So by having that consistent API there, it's really easy to build new functionality that you need for your particular use case. And so when I do the deployments here, it's got a very nice structure in the way that all the deployments are done, where everything is done as code and it's all versioned. So I can just go update an existing deployment, and instead of it throwing everything away, it will just find what needs to change, make those changes, and then it's done. And as you're deploying things, you can also pack lots of stuff on the same machines, but still do this with very predictable performance, because you're able to set memory and CPU limits as needed, so that each workload takes only the resources it's supposed to use. That's also important because it also gives you a consistency. So it doesn't matter which machine you're running on, it's still going to get the same amount of resources. And I'm on the right machine. And so the platform itself, has a lot of core objects, like being able to schedule pods and containers, wrap those up in a replica set, wrap those up in a deployment, but you can also create new object types in it. And so what that lets you do is basically continue extending and adding new functionality onto that. I'll show how you can actually provision databases through Kubernetes in one of the demos in a bit. So once you've got all your deployments done, Kubernetes makes sure that everything stays up and running. So if a node goes down, if a container mysteriously crashes, if I accidentally shut one down that's not supposed to be there, it's always checking the configuration of everything, and if anything's not the way it should be, it just fixes it automatically. So now let me go ahead and kick over into the first demo here. Okay, so that Azure Container Registry build that I started off earlier actually finished while Monty was showing Service Fabric. And so if I go refresh over here, since I've got it up, I have to run refresh. Okay. So now we'll see that I have another container image here in the repository that I just built. But anyway, so getting back to the Kubernetes side. So everything in Kubernetes can be managed either from the command line or through other tools built on top of it. So, so just starting off here, there's a tool called kubectl, and it can be used to look at anything in the Kubernetes system. And so for most commands, it's got nice built-in help and gives you suggestions on what you can do. So if I do kubectl get node, it's going to show me all the machines that are part of this cluster. And if I want to see more details or do queries, you can customize all that formatting. So what I have here is 2 servers that are running Windows Server Data Center, and then I've got 2 more workers that are running on Ubuntu Linux, and then this one is actually running all of the core scheduling stuff. This is just a dev cluster I set up. So if I needed to handle, if I wanted more failover redundancy, I would typically deploy something like 3 nodes to handle all the scheduling so I can establish quorum. I can scale it out to more nodes if I need to for a much larger deployment, but this is all things that you can easily change after the fact. And so the next thing I want to show real quick is if I do kubectl get pod, all namespaces, we can see that I actually have a whole bunch of stuff running on the cluster already. One of the things that I'm actually running right there is the Kubernetes dashboard itself. So there's a nice feature of kubectl that can be used to proxy stuff. So when you first set up something with AKS or whatever tool you're using to build your Kubernetes cluster, they're always going to give you a config file back. And so that config file will have things like the certificate, the host name, all the parameters you need to connect to it. And so you just set that in an environment variable, and then you can connect from there. So what the proxy does is it's giving me a nice secured connection that I can use for the Kubernetes API as well as the dashboard. So this is the Kubernetes dashboard that's running on my server or running on this cluster right now. And so I can still see things like all the nodes that are running, and I'll be able to see the workloads as I deploy them. So now let's go ahead and do the first deployment. So this first one I'm going to deploy is going to spin up a cluster running Internet Information Server. And so this deployment is going to create a replica set. Initially, it's going to have just one instance, but because I'm declaring a replica set now, I can easily change that number later. And then I've picked a container to run, what ports to expose. I've told it, only run this on Windows because this app's not going to work on Linux. And then the other important thing that I'm doing here is I'm actually requesting a load balancer. And so the load balancer has something that's called a selector. So I'm saying find all the apps that are called, IIS 1803. So all these pods that I deployed are tagged with that app. This is important because Kubernetes will make sure that these things are automatically hooked up. So whenever you want to be deploying multiple containers that need to be able to find each other, or you want to have a service like a load balancer or a configuration manager or anything like that, locate other containers that are running, you can do all of that through labels, which lets you build out really nice topologies for all this. So I'm going to do kube control. I'm going to deploy this into a namespace called web. A namespace is basically just something that you can use to capture everything together in a project. So you would typically do one namespace either per like working group or per application. That way you can aggregate all the resource usage and actually control who has access to those resources. So I could have a namespace that's running a payroll app, another one that's running my front-end web server, and I can control who has access to each. So the deployment's been created. Now going back to the dashboard here, okay, I'm on the web namespace. So let me go back to the overview. Okay, so now I see that in this namespace, I have one deployment running right here. That deployment has the replica set. It's currently running just one node. But actually, let me go ahead and just scale this out right now. So if I go back to the deployment, there's a nice little scale button here, so I can just say, I don't want one server, I want 10 behind this load balancer. And so we see that the replica set was updated. And then if I refresh this, you'll be able to see that the status is changing as things are happening there. And I'll actually go back to the overview here. Okay, so when I look at the overview for a namespace, it shows me all the deployments all in one page there. So that first container that I started was already there, and now the rest of these are in the process of coming up. And if I look more closely, we can see that it's actually evenly distributing these across the two Windows nodes that I have here because they both have the same resources free right now. And then down here at the bottom, this load balancer that I created now has an external endpoint that's available. So that's an Azure public IP. If I click on that, web services are already up and running right away. So really easy to deploy that stuff, and everything is done in a completely repeatable manner because it's all just code. So if I wanted to create multiple instances of this, I could deploy it over and over again, different namespaces, whatever I want to do as part of that deployment. So let me go ahead and refresh this and see if those other pods are up yet. Okay, yeah, so in just less than a minute there, the other 9 pods started up. So now I've got 10 running across the 2 nodes. If I go over here and delete one of these, I'm just going to be a bad admin and I deleted the wrong thing. The replica set already realized that it was not meeting the ask that we had of keeping 10 containers alive, and so it already started a new one in its place there. Actually, refresh that. Yeah, and so now it's already got another one up and running. So this is all very, very quick, and very good because everything can just heal. If I were to lose a node, it would notice that within a few seconds, make the right adjustments, and then keep going on there. So that's just a really basic deployment. Next, I want to go ahead and show something that's a little more real world. Okay, so this is a sample app that was initially developed to show off Visual Studio in .NET several years ago. It's an example of something that could be lift and shifted into containers very easily. And so in Visual Studio, we actually use the support in here to be able to build a Docker file and a Docker Compose file for this project. And that's basically, all it took was just a couple of clicks to get that build. And then once I had those containers built, then I went ahead and let me find the right one here. And so I've also created the Kubernetes deployment files that I need for this. So I have since I'm going to do a test deployment first, I'm actually running the SQL Server Developer Edition as a container. This is not highly available, it's not going to be backed up, but it lets me bring up the test environment very, very quickly. And then I have another pod specified that will actually run that web container. So let me go ahead and create these real quick. Got the -F. Okay, so I've got my deployment. I want to have a service endpoint. So what the service endpoint in Kubernetes does is it basically gets an IP and a host name that's local to the cluster that can always be used to find that service that's running. So it doesn't matter where my database is running. The web service can always just refer to it as DB for database, and it's going to get routed to the right place. And then I need the web deployment and the And the other thing I'm doing is I'm actually putting a secret. So this is going to be the database password that's needed. I'm going to store that directly in Kubernetes, and then it's going to broker that out to each of these containers as they're created. And since I forgot to create that first, I'm probably going to have to restart one of those containers so it gets it. So let me see if that's everything I need. So I'm going to change namespaces over here to the test deployment that I have here. Okay, so I've got two deployments. I've got the web, I've got the database. Each one is up and running. I've got the front end, and because I forgot to create that secret, there's a good chance it's going to not have the password, but let's see what happens. Okay, it's up and running now. So now I've got the web service running across, I've got a test database deployed in one container. I've got a service created so that way the website can find it by name. Website's up and running, and I've got an Azure load balancer that was automatically configured on top of this. So I didn't have to go figure out what all that network topology was. I just defined the connection points in Kubernetes, and it made everything happen automatically. So I'll come back to this app and show production workflow using Azure SQL in just a minute. So what I had running in this case was I had a cluster where I had 2 Linux nodes and 2 Windows nodes, but Kubernetes was managing all of those together. And then I created the web app, the test database, using Kubernetes, and that worked just fine. So I want to briefly talk about where we're at in this project. So the Kubernetes project founded the Windows Special Interest Group right around the time that Microsoft launched Windows Server 2016. And so, it was we had individuals from Apprenda, Cloudbase, Ticketmaster, Docker, Huawei, and I believe from Red Hat as well. I forgot to put them on there. But a whole bunch of people came together and said, hey, we want to use the same management solution across all the machines in our environment, not just the Linux ones. And so that picked up steam really, really quick, and then they gave us a lot of feedback on what we needed to do to make Windows work better with Kubernetes. And so when we had, so we basically started making investments in the Windows Server platform in the semi-annual channel releases, so that way we could support things like the networking model that Kubernetes needs, and then and as well as some of the storage stuff. And so we built up momentum very quickly, and a lot of partners out in the industry, like Docker and Red Hat, have said that they're going to support Windows containers with Kubernetes as part of their commercial offerings. So if you're looking for something to run in your private cloud, be sure to talk to both of them. We've also had a lot of customers say that they want consistent network policies that can be applied to both Windows and Linux nodes. Kubernetes has great support for network policies, but it's not something that's built in. Everything in Kubernetes is designed to be pluggable. So there's a project called Calico that gives you really good fine-grained control over all the ingress and egress that you want. And so when I'm doing that deployment, if I wanted to lock down the network, the first thing I would have done was deployed the network plugin earlier, but then I could, as just part of that same deployment, I could say, here's what the network security policies are. So everything that's going to be deployed is auditable in one place, because Kubernetes is that source of truth, the deployment is code, and every time you make a change, you've got code that you could just check in and actually review, so you could say, what's changed over time. And then with Windows Server 1803, we've improved the storage. And so, we've spent the last 2 years, working in tandem between, the open source Kubernetes project and, of course, the Windows operating system, getting ready to be able to launch this in production. So Windows Server 2019 is where all those features that, we sort of, experimented with and polished off in the semi-annual channel are now coming into this long-term servicing channel release. And so right now what we're doing in the open source project is focusing on fixing the last bugs, doing stability testing in Windows, so that way we can get it ready to launch in all these different services. And so like Azure Kubernetes service, where I work, we're already working on a preview right now. Docker's announced that they're working on it. Red Hat, we've actually shown a demo before. And then within the Chinese market, Huawei Cloud is also running Windows Server containers under Kubernetes as a preview. So there's going to be lots of different places that you can run containers with Kubernetes, and it's all going to work exactly the same way. So Azure Kubernetes Service is Microsoft's service offering that's designed to make Kubernetes really, really easy to use. You just pick the size of the cluster you want, the version, and then it deploys it. Because everything is using the same Kubernetes API, that means that you can use whatever tools you want on top of that. So most of these projects here, like Helm and Draft, are all part of the Cloud Native Computing Foundation. They're open source projects. There's a lot of contributors to them, and they're moving very, very quickly. And then there's a lot of commercial solutions as well that are built on top of Kubernetes. So like if you're looking for things that can do extra auditing and stuff like that, scan your containers, there's security vendors that work on top of that. They can connect to your Kubernetes cluster, see what's deployed, and then go scan those containers in your registry for you. So there's lots of things you can do and build on top of that. And one of the ones I want to call out here is something that we've been investing in called Open Service Broker for Azure. This is actually part of it's an implementation of the Open Service Broker standard, but what it does is it makes it really, really easy to consume cloud services. And so, if I wanted to do something like, deploy a highly available database in containers, well, then I need to come up with a strategy to say, okay, I'm going to need, 2, 3, 4 containers. I'm going to need a place to persist all that data in the back end. And I end up engineering a pretty complicated solution. But when we've got things available like Cosmos DB and Azure SQL, all the high availability, backup, rollback, and even geo-replication are all features that are built in, and they're just checkboxes. And so what that does is it lets me bridge the gap between my Kubernetes deployment, where I've got the nice control over my apps, and being able to very easily adopt those cloud services. So I'm going to go over here to my next deployment. So this one, I'm actually going to use a tool called Helm. Helm is basically a package manager for Kubernetes. So, when I did that first deployment, I had probably something like 20 lines of code up there. As you've got multiple containers that need to be deployed, those files can grow really, really quickly. And so rather than going through all that same work for every single deployment, instead, what you can do is use Helm to wrap all that up into a template. And then with the template in place, you can just specify a couple basic values, and then it will fill out the rest for you. So I've got a template created that's going to deploy the same project, but what I did was I set it up with a few simple questions. Do I want to use SQL Developer Edition, or do I want to use an Azure SQL database? And so this section is going to be used by passed to Service Broker. So I'm picking the size of the database instance I want. And if I want to deploy different versions of my app, I can just update the container here, and then Helm will do the deployment for me. So I'm going to do a Helm install namespace. I'm going to put this one in a different namespace so I can monitor it separately. And so what Helm is doing is it's processing all those templates, figuring out all the containers and all the changes that need to be made. And so before, when I was typing something like, 5 or 6 commands for each step of the deployment, here Helm wrapped all of that up into just one. And so with the Helm install command, it created all that stuff for me. So I've got a deployment for my container, and here's where the Open Service Broker comes in. I have service bindings and instances for the Microsoft SQL Service. And if I use the Service Catalog tool, okay, so it's still in the process of deploying there. So what this is doing is, this is actually calling back out to Azure for me automatically. It's going to create the database, which means it's going to get a unique username, unique password. I don't know what the DNS name is going to be yet. I don't even know what port the database is going to be on. But it's going to get all those details from the service broker and put them directly into the container deployment for me. And in order to make all that possible, I didn't have to rewrite my app to consume that. What I did was I just added a new assembly to my class called Configuration Builder. This is something that was debuted in .NET, I think 4.7. So the code never references it, but within the web config, I can basically just take in all these things as parameters and build up the database connection string automatically. So it doesn't matter where I deploy this container, as long as these parameters are passed in, it's going to do the right thing and connect to it. And what Service Broker is going to do is take all those things, encrypt them, put them in a secret stored within the Kubernetes key value storage, and then complete that deployment. So while that's going, I'm going to go back over here to the dashboard. And if I go to the other namespace here, I guess I should go to overview. Then I can monitor what's going on here. So right now the pod hasn't started yet because it's going off and provisioning my SQL database. So if I go look at the resource groups here, since I had a namespace called ff-osba, it actually created a resource group to hold all the things that are being provisioned through the service broker here. So now I can see that there's actually a database and a server that are in the middle of being deployed there. Okay, so service brokers deployed a database there, and if I hit refresh over there, I think it's going to be up and running now, or very soon. Okay. All right, so it's already got the endpoint, but it's just finishing getting the secrets and the stuff populated to run that. So this will start up in a few more seconds. So I'll come back to that in just a minute here. Okay, so that's the demos, that's what I just deployed. And then also, if you're working with Docker or Red Hat, be sure you talk to them because they've got previews that are going to be coming up soon for customers that are running on-premises. And then, of course, we also have a Red Hat managed OpenShift offering coming on Azure as well. So if you've got a preference for one of those environments, that's going to be available with Windows support as well. So anyway, Windows containers are one of the easiest ways that you can lift and shift one of your existing applications, deploy it using modern techniques, and then you can start running other microservices next to it. And so it gives you a way to build some agility into your system. And then we've got a choice of services on Azure, ranging from simple things like Azure App Service that make it really easy to get your first website up and running in a container, to Azure Service Fabric and Azure Kubernetes service that can handle much wider distributed applications. You get to basically design things as you go to meet your needs. So that's all those services. And then be sure to check out the past recordings for the other sessions if you're looking for more information on containers in general. And that's the last slide there. And then the deck's going to be online as well. So all of our doc links are available on this last slide here. So anyway, thanks for joining us this morning, and hope you get started on your container journey very soon. And looks like we got about 3 minutes for questions. So if you got any questions, please step up to one of the mics.
Thank you.